All right, thank you. Welcome to Everything is Awful. I will be your cloud native devil's advocate today. I'm Flynn, I'm a tech evangelist for Linkerd. I work at Buoyant. Before I did that, I was the original author of Emissary Ingress. I'm also a co-lead of the Gamma initiative. This probably means, oh, I can take my mask off too. This probably means that I owe some of you an apology for things that I've inflicted upon the ecosystem. You can reach me at Flynn on pretty much all the CNCF Slacks. You can email me at flynn@buoyant.io. And we shall start by looking back at the original promise of cloud native and Kubernetes and things like that. You know, there's one other thing I should say too, which is that looking back over the abstract, I remember talking about some awfulness with the distributed systems. I owe y'all an apology. I ran out of time before I ran out of awfulness. So we won't be getting to that. The original promise of cloud native, y'all probably remember, everything was supposed to be awesome. Don't worry about the hardware. Don't worry about networking. Don't worry about networks and data centers and power and cooling and all of this stuff, because the cloud will solve everything for you. And y'all probably know how that has worked out in practice. Everything is not awesome. Everything is different, but it's not awesome. I think there are some things that we can do to substantially improve the awesomeness of this world. That's what we're going to talk about. But in order to do that, well, basically everybody in this room is a Kubernetes expert of some version, right? Probably some of you are not people who are going, oh yeah, it's cool, I'll knock out 5 different API servers before breakfast. But if somebody walks up and says, hey, can you help me with Kubernetes? You can do that, right? I would like everyone to forget that for a moment. I would like everyone to look back at Kubernetes through the eyes of a beginner for a few minutes, where we have things like this, where we go, oh, here we have a Kubernetes cluster. A Kubernetes cluster is a container orchestration engine. Okay, great, what's a container? Is a container like a VM? No, a container is not like a VM. A container is kind of a little bit like a VM if you take the operating system away, which is why we can go and run multiple containers inside one VM with one operating system, and this is awesome. And when we do that for Kubernetes, we call it a node, which makes it that much more awesome. Of course, where one node is better, or one node is good, multiple nodes is better, right? And actually, I lied a second ago when I was talking about VMs. They don't have to be VMs. They could be real machines, or VMs, or whatever you want. But we'll take a bunch of them and we'll slap them in together and we'll call that a cluster. But of course, when we do this with a cluster, we have to have one node become the master node and the other nodes become, I don't know, non-master nodes or something like that. And the orchestration layer comes into this because Kubernetes has to worry about things like the network, where there's really only kind of one network in your node or in your cluster or something like that. But all the pods, all the containers, right? Containers, all the containers are supposed to be able to talk to each other in this magic way. So the orchestration layer has to worry about that and just make it work in much the same way that it has to worry about keeping track of how much CPU you have, how much CPU is being requested. It has to worry about managing RAM. It has to worry about things like GPUs, and it has to do all of this when there might be not the same amount of these resources in every node. This is complicated. This is a big job. It's a sufficiently big job that you could be forgiven for wondering why we don't just go back to running them all in real hardware, but that is not the cloud native way. So let's go back here for a second and just look at our single cluster with a bunch of containers in it. Let's look at this now from the perspective of an application developer who is not, it turns out, going to be able to think about containers. You have to think about pods instead, which is the Kubernetes abstraction for containing containers. It could contain multiple containers, but let's not worry about that. Let's go back to just one container. We've got our pod. Nobody really creates pods, not a lot. We tend to make deployments to manage our pods, but the deployments create replica sets. Then the replica sets create multiple pods. And you would be forgiven as an app developer for thinking, no, really, I just want to make a pod. Here's my pod. My pod's got a name, and then I got some containers, and the containers all have names, all of which are different from the name of the pod, even though they could be the same text, it's a different name. If you want to do this with deployments, like you really should, now you have to go take that stuff, shove it down into the template for the container within your, the template for the pod within your deployment. And you still have containers in the pod template within the deployment. And your deployment, you'll note, also has a name which is separate from the name of the pods inside, although in practice, the deployment will make pods that have names that contain the name of the deployment, but they're not the same. And let us also not forget that you have to throw labels in here. I want to take a moment to remind everyone that the only purpose of the deployment is to manage pods. That is all it does. But you still have to go through and write these two labels, and you must have those two labels match so that your deployment can find the pods that it's supposed to be managing and not accidentally get the wrong pods, so that if you turn off the deployment, it will kill pods for some other deployment. That's no good. You don't want that. And we haven't even talked about services. We could talk about stateful sets, but we're not going to do that. Let's talk about services instead. Services work this way. Every time you create a pod, the pod gets an IP address. And then the service is the thing you use to allocate a DNS name and allocate a separate cluster IP address. And then the service goes through and finds all the IP addresses of your pods so that when you talk to something using the cluster IP, the service can go through and use kubeproxy and relay it over. I mean, we could use a service mesh for that, but let's not do that. We'll go back and do that later. And you know, this is another one where, since the service is a completely separate thing from your deployment, you need to go through and create the service as its very own separate set of YAML with its very own separate name, which is the DNS name, except for the fact that it's not usually a fully qualified DNS name. That comes later. We're not going to talk about that. You also have to tell it about the type, which is a cluster. We're not going to talk about types. But you have to tell it which port you want it to listen on, which is okay. And you also have to remember to tell it which port within the pods that it's going to connect to, which is also okay. And wait, let's not forget the labels. These are especially fascinating because you'll recall the service and the deployment are actually two entirely separate things. And once again, if you get the labels wrong, you will be picking up pods for other deployments. So when you connect to the cluster IP, some of your traffic at random will go to places it's not supposed to go. Or if you get it really wrong, they will go to nothing at all. Yay. So let's go back to this and talk. I take it back. Let's not talk about namespaces. Let's also not talk about quotas or net policies or limits. Let's not talk about autoscaling at all. Let's not talk about config maps or secrets or CRDs. God, let's not talk about CRDs or endpoints. Yeah, we're not going to talk about ingress, and I should point out that we're not going to talk about the ingress resource or the ingress problem or ingress controllers, which are three very different things that all happen to be called ingress. And we're not going to talk about roles and role bindings, and we're certainly not going to talk about cluster roles and cluster role bindings, which are like roles and role bindings, only they're not because they belong to the cluster. This is not awful. Not awesome. It is awful. Perhaps the most awful thing about all this is that we have come to think of it as completely normal. Everything is fine. No, everything is not fine. So, I feel confident that nobody out there set out with the goal of making this sort of awful API for people to work with. And there's an interesting question as you're dealing with things that you would like to be awesome that turned out to be a little bit less awesome, about whether you're dealing with something that's in the design or in the implementation or somewhere in between. Many of these things actually work out to simply not knowing who your user is and not knowing what your user needs. It's also worth pointing out that the things that your users tell you they need and the things they actually need are likely to be different. And you have to go through and figure all of that out and actually give them what they really need as opposed to what they might tell you they need or what they might tell you they want. The promise that we were talking about with Cloud Native early on was made by people that we would now call cluster providers to people who were sysadmins or infrastructure engineers, you know, that sort of person. It boils down to, suppose you use our hardware instead of worrying about this all on your own. And I mean, obviously there's money involved in that one. They weren't going to do it out of the goodness of their heart. So it was pay us to use our hardware rather than using your own hardware. Candidly, this was actually pretty awesome because it did permit the people who were trying to use these clusters, it saved them from the headache of having to go through and set up their own data centers, having to worry about all this hardware. All of these things are hard, and just using somebody else's clusters did actually make that a lot easier. It probably made it cheaper at most scales. The jury's out on this one a little bit at really large scales, but if you're a startup with 4 people, you can go out and get cloud provider infrastructure and not have to do co-load equipment, not have to go and build your own data center. And that opened a lot of doors. It's also worth pointing out that this only really worked at scale because of Kubernetes. The fact that you can that containerization allowed you to cram more compute workloads onto the same hardware was a win. More than that, the fact that containerization standardizes the interface to running an application meant that it became possible to build a lot of infrastructure that didn't have to be tailored for the application it was running all the time, and it permitted a lot of this scaling. So again, this was pretty awesome. Unfortunately, the people consuming the clusters did not always end up agreeing with all the choices that the people providing the cluster made. I know, this is shocking, right? That never happens. This caused the consumers to end up kind of turning into providers. This is the thing that happens a lot in open source. Oh, I don't agree with the way Google is doing this one. I guess I'll just roll my own instead because that will be simpler. That's a good thing about open source, but it can result in you now having to wrangle your hardware and power and cooling and networking and Kubernetes, which is even less awesome than it was in the first place in some ways. As we talk about this, I'm kind of dancing around this idea of roles, role-based design. So I'm just going to own that. I'm going to start talking about these people using the names the Gateway API came up with for them. We have Chihiro, the cluster provider. We have Ian, the infrastructure engineer. We have Anna, the app developer. In those terms, this would be Chihiro originally pitching the use our hardware idea to Ian. And like I said, it was awesome for a little while. On the other hand, Kubernetes did not start with this idea of role-based design baked into it. And the end result of that over time is that although things are improving, you hear people talking about it now, you hear people thinking about it. For now, Kubernetes does a difficult job providing each of these roles with all of the things that they need, and it does a better job with some roles than others. Also, the Gateway API roles don't necessarily cover everything. Chihiro working for Google is probably different from Chihiro working at someplace like Nike. There's also probably the role of a policy administrator, just that cuts across everything because policy is sort of independent in some ways. And these are interesting things that we need to figure out. If we look at how things are for Chihiro, I think the one working for the cloud provider probably is the best match for how Gateway API tends to look at it. This is somebody who probably gets to spend their time learning about the ins and outs of doing Kubernetes engineering at a low level in order to make providers that they can have other people use. And that's kind of, yeah, that makes a lot of sense. At an end user company, it's a little weirder. And I feel like that role is getting a little mashed in with the infrastructure engineer role. Because first off, there's less detailed information for them to consume than for somebody who's going to make it their career. This is a problem in our industry in general. It's a lot easier to get good information if you're already an expert than it is if you're not already an expert. But also, Chihiro at an end user company is probably still trying to use some managed infrastructure. In the worst case, they're probably trying to use a cloud provider cluster and then go and change things. And that turns out to be something that is particularly an awful experience in Kubernetes. In fact, those two people might end up being two separate roles. I'm kind of kicking that around a little bit and haven't really decided how I feel about that yet. Let's look at Ian for a moment. Ian's probably the winner to the extent that anybody wins, because in a typical case, Ian actually will get to focus on providing a platform that Anna, the application developer, gets to use without having to stress too much about all this hardware stuff. At best, Ian doesn't have to stress about this at all. More typically, Ian probably doesn't have to worry about networking and power, or sorry, doesn't have to worry about power and cooling and physical plant and things like that, while still needing to worry about networking. And, you know, I mean, networking can be pretty awful once you start dealing with VPCs and firewalls and AZs and, oh my God. But still, Ian probably is the one who ends up the best in all of this. Things are actually pretty awfully awful for Anna. Those of you who have worked much with me will be absolutely not surprised in the slightest to hear me say that. The fact of the matter is that we don't ask Chihiro and Ian to learn all the ins and outs of Anna's business applications. We do not go to Chihiro and say, you need to think now about the user experience through this application that our end users use. And we do not ask them to do things like try to make sure, we don't go to Ian and say, we want you to make sure that our spreadsheet here has correct data that's being validated. But we do tell Anna, you have to go learn a bunch of crap about infrastructure. We make Anna learn all the stuff with labels and all the stuff about every Kubernetes API, as opposed to just giving her something that she can focus on to solve her business problems. This is particularly ironic because the applications that Anna is developing are the only reason why we are running clusters in the first place. Nobody runs Kubernetes just to say they're running Kubernetes. Everybody runs Kubernetes. No, you don't, Shane. You run Kubernetes to say that you're learning about it, to say that you're experimenting. You have a purpose beyond simply running the cluster. In the real world, leaving aside Shane, in the real world, the applications that Anna runs are the thing that we are trying to accomplish. If those applications did not exist, we would not be using computing in the first place. It's not even saying we wouldn't do it with Kubernetes. We wouldn't do it at all. Also, you know, if these APIs are awful for Anna, then maybe we should just build something on top that she can use, and that would be easier. And that leads us to some fascinating questions. Should this be a standard part of Kubernetes, or should this just be something that we throw out there for everybody to play with? You know, like the Wild West of annotations. That was great, right? This is a trap, in case anybody missed that. This is exactly the situation that Gateway API landed in. Exactly the same questions. Yeah, we could do this. But the transferable skills are a huge win in Kubernetes. Once you finally learn how a deployment works, you don't have to go relearn it if you transfer jobs. Whereas once you finally learn all the mess of annotations that are, I don't know, Amazon's gateways, if you're going to shift over and use Google's gateways, you have to relearn all that crap. So going through and adding unstructured upper layers on everything throws away that transferability win, which is a huge cost. We do it all the time because we don't necessarily have a choice in the matter, but it doesn't really make Kubernetes as a whole less awful. It can make the experience of a given application developer temporarily less awful. It's not really helping the ecosystem as a whole. Of course, the reality is that standardizing anything is really hard. Getting to consensus on what the different roles need is really hard. Figuring out how to implement it and get it into the Kubernetes core is really hard. If you don't believe me, come hang out with Gateway API sometime. So yeah, Kubernetes does not have APIs that really meet the needs of all of its users right now. And it's difficult to fix this. The easiest way to fix this involves throwing away a key advantage that we have, which is a big part of why this talk is titled Everything is Awful. By the way, I'd also like to encourage everyone, as you think of the title of this talk, you should think of Wildstyle from the Lego Movie singing it. Wow, tough crowd. So what can we do about this? How shall we alleviate some of this awfulness? These are ideas. Let me point that out. These are not certain to work. They are ideas that I think are worth thinking about and worth talking about. The first one starts with, there are ways I think we can help people make better decisions about how to use Kubernetes and what to use it for. I think we need to recognize the critical role that Anna plays in the ecosystem. And I think there are things that we can do to make her life in particular less awful. And I believe that some of those things will also hopefully go through and make Chihiro and Ian's lives less awful as well. Better decisions probably start simply with education. I really liked the idea that I heard, I think this was at the steering committee AMA. This idea that we can go out and we can produce information, we can produce content to help people understand what Kubernetes solves, what it doesn't, what it's good at, what it's less good at, what sorts of things are really not a good fit for Kubernetes. At Buoyant, we occasionally have people come up and ask us questions about how do you use Kubernetes in an environment that boils down to hard real time? And we kind of go, Why do you want to do that? That does not seem like a great idea. This can be really hard to get across sometimes. Whenever we're talking about education, I think it's important to remember that we have to try to reach the practitioners, but also their management. And that becomes particularly important when we start talking about things like, for those of you who attended my other inspiring, uplifting, feel-good Pulse of Today talk titled How Kubernetes Dies earlier today, when we're starting to talk about how do we preserve investment in the project so that we can arrange for it not to die, reaching the managers is critical. We can also recognize that things are really not great for the application developers and they will need more support. And that might be a particularly important thing to do in the short term. Anna. Anna is the critical role here. Without her applications, we don't have a reason to be here at all. Chihiro and Ian are crucial, but they are supporting roles. And you know, I spent a lot of time as a sysadmin and as an infrastructure engineer, and yeah, this is not necessarily the most comfortable thing in the world, but I think it was Shane, actually, for all that I was mocking him earlier, who was talking about coming into the ecosystem with this mindset of service to the users, and I think that that is a really good idea. Another point that I was making in the How Kubernetes Dies talks is that Kubernetes has kind of become a public good at this point. We assume it's going to be there. We rely on it being there, and that makes it very important for those of us working on the ecosystem to try to take the attitude of serving the users. App devs, be nice about this. This is not a license to go through and, you know, be a royal pain or whatever. Just be nice about it. We can also make changes for Anna. I was not able to attend Tim's talk where he was talking about the possibility of, say, maybe we could extend service to make policy cleaner. That would be a good thing. But just as a straw man, let me point out, there are a lot of developers who would be much happier with an API that looks like this, where there's a first-class application thing where you talk about the name of the app, the DNS name of the app, what ports it wants, and its deployment strategy all in one. That's probably also awful for the implementers. But, you know, part of the job of working in software, if you're a software developer, part of your job is making your own life harder in order to make the lives of your users easier. So, is this necessarily a great idea? I don't know. Should we think about it? Yeah, I think we probably should. Does this maybe imply that SIG apps should, I don't know, try to be willing to prescribe some stuff? Maybe you need to talk to these people too. It also raises, obviously, a lot of questions about standardization and changes to the core. And so one of the other critical things we can do is put in the work to arrange it so that it's more possible to do core changes in a safe and also reasonably timely way. So, yeah, everything can be awesome, or at least much less awful than it currently is. It's not necessarily going to be easy to do that, but I shall leave you with these words from someone much wiser than myself. Unless someone like you cares a whole awful lot, nothing is going to get better. It's not. Thank you. And how are we doing for questions? So it looks like we do have a couple of minutes for questions. If anybody has any, that's great. If you don't, you can always come up and find me.
Does anyone have any questions?
Sounds like everyone understands exactly how awful Kubernetes is and is prepared to dive into it.
Excellent. All right, thank you very much.